The topic is disjoint subsets. This is useful for detecting cycles in the graph. So this is useful in Kruskal's algorithm. That is the reason I am covering the topic before Kruskal's algorithm. Let us understand what does it mean by disjoint subset. See, if you have a universal set, that is 1, 2, 3, 4, 5, 6 to 10. I have taken an example, a universal set, collection of 10 elements are there. Now if I take that subset, I have two subsets here, A and B. Just look at the things what I am showing, okay? A and B. If you check the numbers here, 3, 5, 9, 4, 7, 8, 10. If you take the intersection of these two, intersection is 5. So if you have subsets A, and if you take intersection with subset B, then the result is 5. So disjoint subset means if you take the intersection, the result is, there is no common element among them. Now, we use this for detecting cycles, so we need some data structure for representing. So how it is represented? We will see the data structure, that is the memory or array, as well as a diagrammatic representation. So two things we have to focus on. So let us see. This is a universal set of 10 elements. I assume that every element is a set in itself. Itself is a set. So for each, there is a node drawn here, 10 nodes are there. And how to show that itself is a set? Negative value shows it's a set. So we use this notation that negative number shows that it's a set or head of a set. For every number in an array, you find it's -1, right? So ignore 0 because I'm not using 0. We have the starting number 1 onward. So ignore this one. So all these are -1. It shows that each element is a set in itself. Like who is the head or parent of 1? Itself. 2, itself. 3, itself, and so on. Now let us come to the next thing. Now from here you can understand, right? Exact meaning you can get from here. Now I have set A and set B. Look at set A, 3, 5, 9. So this means that these three elements together are forming a set. So in this we have to select one of the element as a parent or head of that set. So we'll select one of the element. Out of this I have selected 3 as a head. And the 5 and the 9 are pointing on that one to show that that is parent, or it means we belong to a set where 3 is also present. That is the meaning. So 3, 5, 9, they belong to same set. Now here everything was -1. How we represent here? So I'll show it here. I have an empty array here, that same array. Now I have to show this set A. So for showing that 5 and 9 are shown as children of 3. So at 5 I will write 3. And for 9 also I will write it as 3. Then at 3 I have to write some negative value to show that this is a head or a parent of a set. So I will write -3. Minus is negative. Okay, what is this 3? This 3 means total elements in this one. Yes, there are 3 elements. Next, if you look at this set, 4, 7, 8, 9, there are total 4 elements, and I have selected 4 as a head, right? That number is 4, and the 7, 8 and 10 are pointing on the 4. So 4 is a parent or head. And 7, 9, 10 says that we belong to set 4. We belong to set 4. So 7, 8 and 10. Here I will write down 4, 4, 4. And at 4, I have to write some negative number like -1. So just writing -1 is not much useful. So we write the total number of nodes in this one. Now here total number of nodes are also 4. So I will write 4 here. This 4 doesn't mean this 4, right? This 4 means number of nodes. So total number of nodes are 4, so here 4 is written. This is how we represent sets in an array. So from that universal set, we have prepared one subset A, one subset B. So these elements are like 3, 3, 3. These are forming a subset that is A, and this 4 and the 7 and 8 and 10 are forming a set that is B. These are forming a set. What about the rest of the elements? They are not yet included, so let us put all of them as -1. These are -1. So that's all. This is the representation of disjoint subsets in a universal set. On this we perform two operations that are union and find. Union operation and find operation. Let us look at these operations, and union is also called as weighted union and find is called as collapsing find. So I'll explain what does it mean. I'll remove this and show you. Let us say I want to perform A union B. Perform A union B. This is mathematical operation. Now if we perform union, the set of elements will be 3, 4, 5, 7, 8, 9 and 10. These two are combined together and there is nothing common, so nothing is discarded. Now how do you show diagrammatically? Diagrammatically I have to make any one as a parent, right? Only one as a parent, not both. So which one? Shall I make 3 as a parent for all or 4 as a parent for all? Whoever is having more elements, you select that one as parent. That's what weighted union. That's weighted union. So this is having more elements. So let us put 4 there. And 4 is already having 7 and 8 and 10. Then what about this 3? Along with its children, 3 will be pointing on this one. 3 will point on this. So this is 5 and this is 9. So all these nodes are joined together. They are together, they are connected, right? Under 4. These were independent, 2 different sets. There was nothing common. Now they are joined together, they became a single set. Now let us see how it is done inside the array. Actually the operation we perform inside an array. This is the diagrammatic representation. So what we do is, who is the parent of this set A? 3, right? Who is the parent of this set B? 4. So this is 3 or 4. Which is a smaller negative number, right? Negative numbers. This is -4 is smaller. Means it is having more elements. Or if you take positive, who is greater? 4 is greater. So that is having more elements. So what we do is, the parent of this set will have 4 here. So this 3 says that my parent is 4. Then what about 5? 5 says that my parent is 3 and 3 says that my parent is 4. Now this was -3 and this is -4. Total it is -7. So we add all that together. This means that 4 is having total 7 nodes. Total 7 elements are there in that set 4. So if you watch here, 1, 2, 3, 4, 5, 6, 7 are there. Now if you check who is the parent of 4, 5, 5 parent is 3, 3's parent is 4. So the parent of 5 is 4, parent of 9 is 4, 10 is also 4, 8 is also 4, 7 is also 4. So this is how union is done. So I will write down a simple code for this one here for performing union. Union of head of a set, let us say U, and head of a set, that is V. Let us say head of a set is 3 and this is 4. Let us say I am performing union on this, that is 3 and 4. So for performing this one, I should check whose value is smaller. Actually it is negative, so I should check for smaller. If S of U is less than S of V, then who will become parent? S of U will become parent. But in S of U, we will write down the total value, that is -3 -4 we added and wrote here, right? So that is S of U plus S of V, and then we will change S of V's parent as now U. So we'll make U as a parent if U is greater. Else S of V, we will add these two and write them S of U and V together, right? Then next is S of U will change to V. So that's what. See, this was having less number of elements, so 4 became parent. Otherwise, we can make it other way also. Like 3 will be parent and 4 comes under this, and under this we will have 7 and 8 and 10, right? And here we will have 2 that are 5 and 9. But we don't do like this, because who is having more element? 4 is having more element. Otherwise 3 will become parent if 3 is having more. So just how it looks like if 3 becomes parent, I have shown you. But this is correct, so this is wrong, right? We don't need this. Now back on this one. This is union operation. So as a C language function, we can implement this and we can say it is void union. It will perform union on this one. So one will be made as parent of another, and the total nodes are stored in the parent. This is union operation. Now, one important thing. How to know that there is a cycle? See, suppose the vertices, let us say 5 and 10. 5 belong to which set? Parent is 4. 10 belong to which set? Parent is 4. Oh, they already are in a single set. If you join them, it will form a cycle. If there is an edge from 5 to 10 and if you are joining, it will form a cycle. That's how it is useful. The purpose of making sets is, see, if you take in this case, find 5, 3, find 10, 4, they are in different sets. We can connect them, the edge 5 to 10. If they belong to same set, don't connect 5 and 10. It will form a cycle. That's it. This is so simple thing. To detect whether there is a cycle or not, this is used. So I have already explained you union. Now let us see find. What is this find? Find means we want to find out who is the parent of any node. Parent of 5. So 5's parent is 3, 3's parent is 4. So parent of 5 is 4. Parent of 9. 9 is 3, 3 is 4. Parent of 9 is 4. So find out the parent, that is topmost node, root node. So from here if you see, 9 says 3, 3 says 4, 4 says minus 7 means 4 is the parent. Minus, negative, so it's a parent. So this is find operation. Find 10. 10 says what? If you check 10 says 4, come to 4. This is negative, so 4 is a parent. So find operation means finding out who is a parent. Alright? So let us see this operation, how to find. For find I have written a function here, find u. It means find 9 suppose. So the result should be 4 to show that 9 belongs to a set whose leader or parent is 4. So how to check it in an array? Go to 9, take the value here, s of 9. Go to 9, take s of 9. And go to 3, take s of 3. Go to 4, take s of 4. And if it is negative, stop and take this one. Don't take the value, take this one. That's it. So we have to go on taking the value of s until we get a negative number, right? As long as we are getting a positive number, continue. So for that, I have already taken a variable x and I have assigned that u. Now with the help of x, I will do. So this can be done using while loop. While s of x is greater than 0, means positive. What to do? Inside x, assign the value s of x. That's it. Simple. So if you trace this now, if I say find 9, then x is 9, right? S of 9 is greater than 0? Yes, 3. Then x assign s of x. S of x is what? 3. So x becomes 3. Now next time x becomes 3. So s of 3, is it greater than 0? Yes, it is 4. Then s of 3 is what? 4. So this x becomes what? 4. Then s of 4, is it greater than 0? S of 4? No, it will stop. So what is the value of x now? It is 4. That's all. That's the result. So it means to find the parent of any element, just we have to follow the hierarchy and reach till the negative number in an array. This is simplest. So we got the parent now. Just return x. That's it. This is what find is. So we will find out the parent. Alright. This is a simple function. Now there is one more idea in this one, that is collapsing find. We will try to directly connect to the vertex to the parent directly, so you can find out, explore it by yourself. I have explained you the sufficient required things, that is union and find operation upon set, that are useful in our next algorithm, that is Kruskal's algorithm. So there I will not be explaining you union and find, I will be using them. So that's all in this video. There is a demo also available on this one.